Hi students, so today we are going to discuss one important topic. That one is from principle of calorimetry. As we have discussed earlier that what is principle of calorimetry. Okay, so once again I am revising you that principle of calorimetry says that when we are mixing two objects which is at different temperature, okay, when we are mixing them, then the heat energy lost by hot body is equal to heat energy gained by cold body, and its expression is like that: m2c2 t2 minus t is equal to m1c1 t minus t1. Okay, so here I have drawn one diagram in which I have explained that how this formula has came. So suppose we have one metal ball, this one is one metal ball. Okay, let's consider its temperature is T2, mass is M2, and specific heat capacity is C2. And in one container we have kept one liquid whose temperature is T1, whose mass is M1, and whose specific heat capacity is C1. Here I have considered that this bowl has higher temperature and this liquid is at lower temperature. Okay, so that's why I have written here T2 is greater than T1, means this metal bowl has high temperature and this liquid has low temperature. So this one is our cold liquid, this one is our hot body. Now when I drop this metal ball inside this liquid, so what will happen? The body which has high temperature, which is at high temperature, okay, it is going to lose its heats, and the liquid which is at lower temperature, it is going to gain heat. Okay, and this transfer of heat will take place up to the equilibrium point. Okay, equilibrium point means when both the metal ball and the liquid will attain same temperature. Okay, so I have written here after some time they both attain same temperature, that one is equilibrium. So that time there is no heat transfer. Okay, and I have considered this temperature is our T, and T is what? The temperature of final mixture. When we mix both this, that time after some time the temperature which attained by the both the object. Okay, so this one is temperature of the final mixture. Now I have written some key point here. Okay, in note that see change in temperature for hot body. So here I have considered temperature of hot body is what? T2. Okay, so change in temperature of hot body will be equal to what? T2 minus T, means T2 means initial temperature of hot body minus the final temperature of hot body. Okay, and the final temperature of hot body is what? T. It is going to attain the temperature T, so that's why I have written here T2 minus T. And the change in temperature for cold body, that one is equal to T minus T1, because here I have written higher temperature minus lower temperature for both the cases. So in first case T2 is greater and T is less. In this case T is greater and T1 will be less, because T1 is what? Initial temperature of liquid. Okay, and this liquid is going to gain some temperature from this hot body, and after that it will attain the temperature T. So that's why here I have written T minus T1, because cold body temperature is increases. Okay, so that's why I have written T minus T1. So when I put this all formula here, so we will get all values here, we will get formula like this: M2C2 into T2 minus T is equal to M1C1 T minus T1. Now there is one special case is there, when in question they will mention you that the vessel in which we are mixing both the substance, like we are mixing metal ball and this liquid. Okay, when we are mixing any two substance in any container, suppose in question they have said you that we have to consider the heat gain by that container also. Okay, so that time we have to use another formula. So let's consider here M is what? Our mass of the container in which we are mixing hot and cold body, and C is the specific heat capacity of container. Okay, so one point you should remember that, see, the container temperature will be same as the liquid temperature which liquid we have placed here. Like suppose here this liquid we have kept in container, its temperature is T1. Okay, so this vessel has also the temperature of T1. ओके बिकॉज कोई भी सब लिक्विड को जिस कंटेनर में रखेंगे वो उसी का टेम्परेचर में रहेगा जितना टेम्परेचर में लिक्विड है. सो कंटेनर का टेम्परेचर और लिक्विड का टेम्परेचर हमेशा क्या रहेगा, सेम रहेगा. अगर यहाँ पे हॉट लिक्विड रखा हुआ रहता तो जो हॉट लिक्विड का टेम्परेचर है उतना ही टेम्परेचर मेरा कंटेनर का रहता. ठीक है. सो दैट्स व्हाई आई हैव रिटन हियर द इनिशियल टेम्परेचर ऑफ कंटेनर विल बी सेम एज द टेम्परेचर ऑफ लिक्विड which is kept into it. So in this case, suppose our liquid at temperature T1, so our container is also at temperature T1, so that one is initial temperature of container. Okay, so now we are again use the principle of calorimetry. So according to principle of calorimetry, heat loss by hot body, in this case this metal ball is going to lose the heat and the container and liquid both are going to absorb the heat which is lost by this metal ball. Okay, so that's why I have written here heat lost by hot body, in this case that metal ball, is equal to heat gain by liquid plus heat gain by container. Okay, whatever heat is lost by this hot body is going to gain by liquid as well as the container. So that's why I have written like this. Okay, now again put the formula for heat for cold body and hot body. So I have considered hot body mass as M2, a specific heat capacity C2. So I have written M2 C2, then change in temperature for hot body T2 minus T is equal to M1 C1 T minus T1. This one is for liquid. Okay, so M1 C1 T minus T1 plus MC T minus T1, because here in both the liquid and container change in temperature will be same. Okay, T minus T1, here also T minus T1. So take out this T minus T1 as common, so we will get expression like this: M2 C2 T2 minus T is equal to M1 C1 plus capital M capital C into T minus T1. So this one is the expression for heat gain by